In this video, we will solve proportional equations for the value of the variable. So first, what is a proportional equation? A proportional equation compares two ratios. It's also called a rational equation. So this is an example. 4/3 equal to x over 6. This is a proportion. So we're comparing 4 to 3 on this side and x to 6 on this side. Here's another example that's not as simplistic. We have 2 over 10 and 4 over n plus 5. So what we're going to explore is how we would solve these. Now, how do we solve this? Well, when it's this simple, you can just think about it. You know that 3 times 2 is 6, so 4 times 2 must be 8. So we know that that's our answer. Let's look at how we would solve it algebraically. We notice on both sides that we're dividing by something. On this side we are dividing by 6, and on this side we're dividing by 3. So let's undo those operations. So first we're going to multiply by 6 to get rid of this 6. And we're ending up with 24 over 3 equals x. We're going to multiply by the 3 and get 24 equal to 3x. So here we divide by 3 and our x is 8. Now with this example, it seems like overkill to go through all these steps, but I'm trying to lead you into a more complicated example, one that maybe looks like this. We notice we're dividing by things on both sides. So I want to multiply by n plus 5 to get rid of the n plus 5 on this side. And it becomes 2 times n plus 5 over 10 equal to 4. Now I've got to get rid of the 10, so multiply by 10 on both sides. That reduces away on the left, and then I have to multiply the 4 times 10 on the other. Now this equation looks like one we're used to solving, where I distribute, subtract the 10, and then divide by 2 to get that n is 15. Now, we noticed in both of these examples that we just did that we were multiplying by the denominators. So we're hoping maybe to find a more efficient way. This was actually the very first example that I did. Notice that we're multiplying by the 6 and by the 3 on both of those to jump to the 24 is equal to 3x. What if we could do that in one step? So what if we could jump from here to here without having to do this in 2 steps? That's where cross multiplication is going to come in. So instead of multiplying by the 3 and the 6 separately, what we're going to do is we're going to cross multiply. Because what happens on that right hand side is the 6's go away. What happens on the left hand side is the 3's go away. So I'm really just multiplying that opposite side by the number in the denominator. That skips those 2 steps, and we get directly to 24 equal to 3x, where we can divide by 3 and get that x is 8. Let's look at the other example. So here we can multiply by the n plus 5, and notice it cancels away on the side where it's located. So we're really just multiplying the 2 times the n plus 5. Here we would multiply by the 10, but it ends up getting multiplied by the opposite side. So we're multiplying the 2 times the n plus 5 and the 4 times the 10, which is how we form that x for that cross multiplication. So we have 2 times n plus 5 equal to 40, and then we can solve from there and still get that n is 15. Okay, let's try the efficient way with this example. So what we would do is we would cross multiply. So we're going to multiply the 2 and the y and the 5 times the y minus 3. And we will end up with this equation. 2 times the y, the 5 times the y minus 3. From here, we distribute, move over the 5y, and divide by -3. So we end up with a value of y equals 5. Let's try this with another example. We would multiply the 3 and the k plus 9, and the 5 and 2k minus 3. Next, we would distribute, subtract 3k from both sides, add 15 to both sides, and divide by 7. And now we see that k is equal to 6. The next examples are all on your own problems. So the first one, 2, 3, 4, and 5.